Flammability of Household Items by Shira Mack, Serena Goldstein, Jude Finkelstein, and Roy Mendelson. Our research question: what household objects are the most flammable? What are effective replacements for them? These are the objects that we tested. The regular objects were pine, oil-based paint, and cotton, and the replacement objects were oak, water-based paint, and polyester.
We chose these objects because these common household objects are often found in the dining room or kitchen, which is where most fires occur. And by educating the public about replacement for flammable items, we are minimizing the risk of household fires. We hope to educate about which objects are the most flammable and what the best replacements are for these flammable objects. Our procedure is to hold a 7 by 7 centimeter piece of material with fire tongs. Roy trains a laser thermometer on the object. We hold a match or lighter to the object, and we start the timer when the object caught fire. We stop the timer when the fire died out.
And here's a video of one of our shirts trials for the cotton shirt. Oh, oops. So as you can see, like the laser thermometer is trained where the fire is. Yeah.
Predictions and results. Why were our predictions correct?
So our predictions for our wood experiment was that pine and oak would both catch fire easily, and we thought that because they're both used to build fires. We thought pine is more flammable because it is less dense, and that means there's like more oxygen inside of the material. So our results. So an error that we found was that we tested these on the roof, which means there's a lot of wind. So I think that could have affected how long the fires lasted. So we found that pine is not very flammable. It took 15 seconds to ignite and only had a temperature increase of 160 degrees Celsius. It was more flammable than oak because oak never even ignited.
So our predictions for the paints were that the oil-based paint would be more flammable than the water-based paint. And we thought this because oil-based paint contains linseed oil and water-based paint doesn't. And linseed oil contains cellulose, which is also found in like cotton shirts and paper and other things that are very flammable. So we thought this would contribute to the it being more flammable. So our errors for paints were that there was not enough oil-based paint to do 3 trials and also not enough water-based paint to do 3 trials. So we did 2 trials for oil-based paint and 1 trial for water-based paint. So our data might not be as exact. We also accidentally stopped the timer during one of the oil-based paint trials, so we had to estimate. And so that could have thrown off our data. And oil-based paint, one of the oil-based paint trials, the paint dropped into the sink early, which could have extinguished the fire earlier, making the time that the duration of the fire less. Our results are that oil-based paint is more flammable because as you can see, it has its temperature, the highest temperature is 448.6 degrees Celsius, which is much higher than the water-based paint's highest temperature. And also the duration of the fire was a lot longer. And even though we know this, it takes a little bit longer to ignite. So that like goes against our data, but yeah, and also oil-based paint is safer because some water-based paint can be toxic and can contain materials like mercury and other stuff.
So our prediction for our shirts were that the polyester shirt would be flammable because they contain plastic, and plastic has a low melting point. However, we thought cotton shirts would be more flammable because they contain cellulose. And from our research, we know that cellulose is a more flammable compound than plastic. Even though cotton is more flammable, we think it's a better replacement because it is safer. The plastic and polyester congeals and then sticks to the body, which can like give severe burns. So that would be very dangerous.
So our results for shirts was that, like as we thought, cotton is more flammable than polyester. However, polyester congeals, making it less safe, and therefore cotton was our suggested replacement. So so the duration of the fire for both of them was about the same, but the polyester took longer to ignite, which would make the cotton more flammable. But as we said, it congeals, and the cotton had a higher temperature. Here are our sources. Thanks for watching.
Thanks for watching.
Any questions?
All right, thanks, guys.
Harry Troy.
Wait, can you hear me?
Type your question,
Wait.
Harry.
You're breaking up a lot, Harry.
Can you hear me? Alright.
Harry, type your question.
Yeah, I know.
Anyone else have a question?
As long as we're waiting for Harry to type his out, I thought this was a really interesting project. Can you just clarify your conclusions overall? Did you find that the materials that you thought would be less dangerous were uniformly, or was there some mix? Just give us like a summary of all of the conclusion.
So we thought that that like for the paints, we like basically we had the normal household items and the replacement household items, and we had three things that we were testing, which were the categories were paints for woods and shirts. And so for all of them, we found that what we expected was what we got. Like so, our result ended up, our prediction ended up being like our results. The only thing that was different was that the oil-based paint took longer to ignite than we thought it would, and it took longer to ignite than the water-based paint. And so we thought it would take less time to ignite, but it took longer.
Okay, great. I see Harry did type his question, and I know you answered him in text, Jude, but if you don't mind just answering out loud for...
Okay, so to test the paints, we painted it onto a piece of silicone because paint does not stick to silicone. And then we peeled the piece of paint off the piece of silicone, and then we let that on fire. So we were testing just the paint, nothing else.
Right.
Liana?
So do you think your errors were significant? Like, what do you think would have been different without your errors?
Well, for the wood trials, it took a really long time to get both the pine and oak to catch fire. we tested it on 2 days, and the first day it was really windy and they wouldn't catch fire. The second day wasn't as windy, but we think that if we were to test it in the lab, probably we would have they both would have caught fire for longer.
Okay.
Anyone else?
Well, just to go back to the wood for a moment, do you think that would have, do you think that your conclusions from the wood burning trials are accurate?
Yeah, I think we would still find that pine is more flammable, but I think that the data would be a little different because I think there was so much wind that the pine wasn't as flammable, that the oak wasn't as flammable and couldn't catch fire, but I don't think it would be as flammable as the pine.
Right, because it looks like you didn't have any, you weren't able to get any data for the oak, right?
Yeah, it never caught fire.
So that would be an interesting thing to test in the future. My other question was, how did you arrive at your testing criteria? By which I mean the time to ignition and the, I guess, was it change in temperature or peak temperature?
Change in
Peak
temperature.
So why were those the
Sorry,
things?
originally it was peak temperature, but then we changed it to change
Okay.
Yeah.
So then what was your reasoning behind using those two metrics as ways to figure out how dangerous the fire was?
So we measured the ignition temperature of each object, and then we measured how the highest temperature it reached. And we thought it would be better for our graphs to only have like one data point and not two, so it'd be easier to see. So that's why we did the change in temperature.
Okay. And then in terms of time to ignite is, I guess, relatively self-explanatory. But I mean, in terms of making a fire more or less dangerous, um, how does the change in temperature or the peak temperature affect that? Or
I
what is,
mean,
sorry,
the higher the temperature gets, like the more things it can burn. And so that makes a fire more dangerous if it can burn more things. Like it can burn, like at a certain point, it can burn your skin. At a certain point, it can go through like first degree, second degree, third degree burns, and then like also just like objects around the house that can spread fire and burn at different temperatures.
that makes sense. All right. Any last questions? I guess you guys were just perfectly clear. Well, thank you all for presenting. It is not easy, and this is kind of uncharted waters for us in terms of how we're doing this online. Technical difficulties aside, I thought you all did